Okay, so today I want to just review the exercise sheet we did for apparent and absolute magnitudes of stars. So if you look at the slideshow here, so I want to review the concept first. So again, the absolute brightness, or sometimes we say luminosity, is the actual light a star emits. But on the other hand, apparent brightness is how bright a star appears when you view from the Earth. Okay, so the tutorial exercise I asked you guys to do actually, the first page is pretty straightforward. You can take a look at the solution I posted online. I want to spend a little bit of time talking about the second page. Okay, the second page gives you a table which actually there are 4 stars, and then you can see apparent magnitude and absolute magnitude for each star. The problems I want to talk about is number C and D. Okay, so for problem C, okay, the question is asking for stars A to D, state whether the star is closer than, further than, or exactly 10 parseconds away from Earth. Okay, and I put a little note here, okay, on the solution sheet. So saying that apparent and absolute magnitudes are equal when a star is 10 parseconds away. That means the apparent magnitude and absolute magnitudes are exactly the same when a star is 10 parseconds away. So then if you go back to the table, you can see star A, actually apparent magnitude is 1, absolute magnitude is 1. So that means star A is 10 parseconds away. The same thing for star D. Apparent magnitude is 4, absolute magnitude is 4, so they are exactly the same, so that means star D is 10 parseconds away. Okay, but for star B, the apparent magnitude is smaller than the absolute magnitude. That means the star appears brighter than actually it is. So that's why the B has to be closer. So B is closer than 10 parseconds. But C, apparent magnitude is 5, absolute magnitude is 4. So the apparent magnitude actually appears dimmer than the actual light is. So then that's why the answer for C is further than 10 parseconds. Okay. D, would the apparent magnitude of star A increase, decrease, or stay the same if it were located at a distance 40 parseconds? So then, star A we know is located at 10 parseconds. But if we move this to 40 parseconds, then it's going to, the absolute magnitude is not going to change. It's always the same. But the apparent magnitude is going to be, if you move away from, further away, so it's going to appear dimmer. When it's dimmer, the number is bigger, so then it has to be bigger. So you can also see this light here. Okay, so it is also inverted. Larger magnitudes are dimmer.